Hey there, it's Joey. Welcome to Joey's Tech. And in this video of Joey's Tech, we are going to look into one of the most famous problems of all time, sum of all substrings of a string representing a number. Now, this problem has been asked in many interviews, so I recommend you to watch this video till the end. And now we are going to take a look at its problem statement. There you go. So there is an integer 1 to 4 given to you, which is represented as a string. Why string? Because your ask is to find out the sum of all possible substrings of this string, representing the number 1 to 4. That's why it has been represented as a string, because we are talking about substrings here. So you can see the different substrings of 1 to 4 are 1, 12, 2, 4, 24, 1 to 4. I am assuming that the substrings are clear to you, and if you sum them up, then you are going to get 167. Now this number 167 is what we are going to find out in our framework when we give 1 to 4 as an input, and we are going to construct a dynamic programming algorithm for it. Before we move to the framework, I request you to subscribe to my channel if you haven't done it already, and hit the bell icon, because that way you will get notified whenever I release videos like such on dynamic programming for you in future. Now let's move to the framework. Welcome to the framework. We have the string here representing 1 to 4. Now in any program, the individual elements of the array will be represented by the indexes. So 0th index will represent value 1, index 1 will represent second value, which is 2, and index 2 will represent the third value, which is 4. Now let's do a little bit of thinking. So since we are going to solve it using dynamic programming algorithm, so we are going to start from smaller subproblem and move to larger subproblem. So starting from the smallest subproblem, let's consider that we have only one integer in our string, and that is 1. So how many substrings can we take out from 1? Only 1. Alright. Now moving to the next subproblem. So now we have 1 and 2. Over here, if I consider 2 and involving 2, how many substrings can I take out? Remember, I am saying with 2 involved, how many substrings can I take out? So my answer will be 2 alone will be one substring, and then 1, 2 will be another substring. Remember, I am involving 2 because I have already found out the substring involving 1. Moving on to the third element, with 4 involved, how many substrings can I take out? So my first substring will be 4, then I will be having 24, and then 1 to 4. Alright, now let's consider this case. So can I write this case as 4 plus 20 plus 4 plus 120 plus 4? We can write it, right? We can write this case like that. Alright, now let's bring all the 4 together. Okay, and let's bring 20 and 120 on the other side. Now what I can do, I can see that I have 3 4s, so 3 multiplied by 4, and if I take 10 as the common integer, then within braces I'll get 2 plus 12. Okay, so I see a formula here. I see a TP formula here. So if you see, 2 plus 12 represents all the substrings when 2 is involved, or the substrings represented by index 1. Okay, and here if you see, we were considering the index 2. So 3 can be written as 2 plus 1 multiplied by 4, which was the which is the element represented by index 2. So I see a formula over here. If 2 is represented by I, then I have I plus 1, that will make it 3, alright, and then I can say stri. So what is stri? It is 4 plus 10 multiplied by dp, and this is the array which we are going to use to solve our problem. Basically it represents the previously solved subproblem. So dp I minus 1. Okay, I see this formula, and this is the formula that we are going to use to solve this problem. Okay, so here is our dp array, and let's solve this problem using this formula that we have derived. So in the first index, the value which will be populated will be 1, like we did here. Alright, the smallest subproblem. Now our I is 1. Okay, so using this formula, what is the value that we are going to get? So when I is 1, I plus 1 is going to be 2 multiplying stri. So str1 is 2. Then I have 10 multiplied by dp, 1 minus 1 is 0. Alright, so 2 multiplied by 2 is going to give me 4 plus 10 multiplied by dp 0, which is 1. So 10 plus 4 is going to give me 14. Now I will be having a running total. The running total is going to represent the sum of all the substrings. So at index 0 it was 1. At index 1 it becomes 15 because 1 plus 14. Now our I shifts one cell to the right. So I becomes 2. Now we are going to recalculate this formula for I is equal to 2. So it will be 2 plus 1, 3 multiplied by, what is the value here? 4 plus 10 multiplied by dp, 2 minus 1 is 1. Okay, so what is going to be the result of this expression? 3 multiplied by 4 is going to give me 12. 10 multiplied by dp1, so dp1 is 14. 140 plus 12 is going to give me 152, and my running total becomes 15 plus 152, 167, and this is my answer that I was seeking, for which I constructed this dynamic programming algorithm. Now let's take a look at its algorithm in the next slide. So this is our algorithm. Here the dp array is replaced by sln and the str array is represented by n. You can see that the first element of our sln array will be the first element of our array, our string array, and this res is going to represent our running total. Then we have a for loop which is going to start from first element and it is going to go all the way till the last element. This particular line of code represents the formula that we calculated, and res will keep on incrementing like we did it in the framework, and this res in the end will give us our answer. The time complexity of this dynamic programming algorithm is O(n). So this concludes this video. I hope you enjoyed watching this video. I hope you learned from this video. Do give it a thumbs up, don't shy away. I look forward to help you with programming and algorithms in only for this video. Goodbye and take care.